Okay, we'll continue on with some more graph interpretation. Now let's look at box plots and how we would interpret a box plot. So here I have some data about the breakfast items at McDonald's. So we have 24 different breakfast items, and we're looking at the amount of fat in grams that are contained within these items. We want to look at that distribution. So notice here I have given you some important information. We have our 5-number summary here and our sample size. And then we have our box plot that shows the data. So we might give you something like this. We might give you a box plot. We might give you a 5-number summary. Maybe we'll just give you a box plot. We'll ask you to interpret what you see in the graph. So here's something we might ask you. What is the maximum amount of fat in this data set? So this is not a trick question. You have the maximum right here, 59 grams, and you see that maximum here. So part of the reason I asked this question is because I wanted you to know that even though the maximum is an outlier in this case, that is still our maximum. So we would still report that as the maximum. What percentage of items have 18.5 grams of fat or fewer grams? So here we can see 18.5 is at quartile 1. And hopefully you're remembering that quartile 1 is the 25th percentile. 25% of our data falls below quartile 1. So the answer here would be 25%. How many items, so we're looking not for a percentage but a number, how many items have 34 or less grams of fat, or 34 or more grams of fat? So 34 is quartile 3. Here's quartile 3. So we know that, again, above quartile 3, we have 25% of our data. Here we have 50%. So our IQR gives us that middle 50% of the data, so altogether we have 100%. So 75% of our data falls below quartile 3. So if we want to know how many items have 34 or less grams of fat, we would need to know what 75% of 24 is. So to find this, I would just take 0.75 times 24, and you'll see that that'll give you 18. So 18 items have 34 grams or less, and then 6 items would have 34 or more. So the remaining 6, or 25% of 24, would be in this area up here. So knowing, again, understanding that certain values cut off certain parts of the distribution can be really helpful to answering these kinds of questions. Knowing that the median cuts off 50%, so 50% below the median, 50% above. The median is the 50th percentile. The IQR in this case would be quartile 3 minus quartile 1. That would give us 34 minus 18.5, or about 15.5. So again, I really apologize that my writing is atrocious, but hopefully you're making sense of things here. And hopefully this is matching what you thought the answers were when you tried to go through these problems on your own. So here's another box plot. The box plot below shows the distribution of the weights of a random sample of 60 corgis. So corgis are dogs. Here's a corgi if you're not sure what they look like. So the mean is not plotted in this box plot, but I want to know what you would expect it to be based on what you're seeing here. Do you think it would be larger than, smaller than, or equal to the median? And remember, this is our median. That line in the box is our median. That's the middle value in the data set. Well, I'm hoping you're looking at this and saying, hey, this distribution is skewed to the right. We have this long tail out here. We see that our median is closer to quartile 1 than it is to quartile 3. We have a smaller tail over here. That's all evidence that's pointing out a distribution that's skewed to the right. And if the distribution is skewed to the right, the mean would be larger than the median. So the mean, remember, is pulled toward the tail, pulled toward the more extreme values. 5-number summary. So we might give you some data and ask you to compute the 5-number summary here. So I will give you a second to think about what the 5-number summary would be and why. Okay, so here again is our data set. So one thing we tried to do is we tried to put the values in order for you to make it a little easier. But remember, if the values are not in order from smallest to largest, the first thing you would want to do is put them in order before you start trying to compute your 5 numbers. So we know the minimum is one value, it's 0. We have quartile 1, which is 12.5. The median is 22, quartile 3 is 40.5, the maximum is 75. So the maximum and the minimum are always pretty easy to figure out. We want to know what the median is. Why is the median 22? So this is a case where we have an even number of values. We have 12 values in our data set. So remember, we have to go to the center 2 values in this case, since we have an even number of values. That would give us 19 and 25. And the average of 19 and 25 is what gives us 22. So we get 22 by taking 19 plus 25 and divide it by 2. To get quartile 1, again, that's going to be the average of 11 and 14. And then to get quartile 3, that's going to be the average of these middle 2 values, or the average of 36 plus 45. Oops. So remember, when we have an even number of values, we have to figure out some averages in order to help us determine what the median and our quartiles should be. What shape do you think this distribution will have? How do you know? So one thing you could do is you could actually put a box plot together, or you could look at how the quartiles are comparing to the median. You could look at how the minimum is comparing to the median, how the maximum is comparing to the median. One thing you might notice just from eyeballing the data. And I encourage you to do what you think is easy. So if it's easier for you to have a good visual representation, I would suggest drawing out maybe a number line here, finding where your quartiles fall, finding where the median falls, drawing the box plot so you can actually see. But you might be able to reason through it just from looking at these numbers. So clearly 0 is closer to 22 than 22 is from 75. And 12.5 is closer to 22 when compared to 22 and 40.5. So in other words, what I'm trying to say is we have our median, and I think I drew a picture of this somewhere. So we kind of have a case where we have our median. It's a little bit closer to quartile 1 than it is to quartile 3. It's closer to our minimum than it is to the maximum. So again, you're going to have a situation that looks a bit like this, and we know that's pointing out skewness to the right. So there's that long tail that's going out toward our larger values. Half of the data is scrunched down here, and then the rest is kind of spread out toward those larger values. So skewed right. So hopefully all of this just made sense, but again, I would definitely draw the picture, try to lay it out, and that hopefully will help you see what I'm talking about. Are there any outliers in this data set, and how do you know? So remember how you would figure out if you have an outlier. So we need to use our 1.5 times IQR rule. So what's the IQR in this case? Our IQR is 40.5 minus 12.5. And that's going to end up giving us 28. Then we take 1.5 times 28, and that's going to end up giving us 42. And then what do? So we take Q1 minus 42, and then we take Q3 plus 42. So if you do that, you're going to get negative 29.5, negative 29.5, and here you're going to get positive 82.5. And so remember, you have these two numbers now, and you want to see, do you have any values in the data set that are less than negative 29.5? No, our smallest is 0. Do we have anything that's greater than 82.5? No, our largest is 75. So we have no outliers according to the 1.5 times IQR rule. So we really want you to have an understanding of how you would apply that rule. And we also want you to have an understanding of just how different values in the data set are going to affect different measures of center and variability. If we took a value out of the data set and we had to recompute things, how would that affect our different measures? Or if suddenly I told you, hey, 0, that's actually incorrect, that actually should be 5. How would that impact some of the numbers that we've just computed? How would that impact things like the standard deviation or the average? So think about things like that. Okay, so our last few problems actually are going to be all about the normal distribution, so I think I'll save that for a new video.